Hi everyone, welcome to part 7 I think of our tracer text model refactor. So since the last part, I'm not quite sure how much work we've done since the last part. I think it was quite a fair bit actually. You can see here on the C++ technical space there's almost nothing left, just what you'd expect to see, which is the model to text transforms. In C# we're a little bit further behind because we need to bring in the assistant, and the assistant is then dragging across all these other guys like traits and so on. So I guess we have two options for today. We could either tackle these guys here. 1 second please. Nothing happening. So we could either tackle these guys here, which are the most obvious thing, or we could tackle these guys and complete the C++ model. The C++ model, I think, is not actually that complicated. I mean, famous last words, I guess, but so as you can see here, in fact, to be honest, you probably want a stitch template as well. So as you can see here, the remaining references that we've got here are all quite straightforward. We have utility. Did I actually start recording again? I did. Utility, tracing, logical, physical, identification, logical, so it's all over the place really, but largely there's only two last references left, which are two things that we're going to carry across. So I suspect there isn't a big problem here. It might even just be the case that we just need to copy across everything, rebuild, and it would just work. Sadly, the only slight problem is, in order to do that, we do need to copy across all of the transforms. Reason being that at present we have some kind of hackery. Don't remember exactly what hackery did. It's been a few days now, but we did some kind of hackery inside of this model, presumably here, and it will fix me now. Oh, actually, no, it wasn't this model at all. It was in orchestration, where so around bootstrapping effect. Fix me. Yeah, here we are. So what we did was we needed to merge the helpers coming from one model. So at present, if you remember, we've already migrated all the helpers to their rightful location inside of the text model, as you can see here. And we are generating effectively two representations for the same technical space. The representation you got here and the representation you have here, the legacy one. And so the problem at the moment is, in order to create a combined physical model, we needed to pick aspects from one side and the other. So what we did is we did a very quick hack. That quick hack basically said, well, go and grab things from the new technical space and just merge that into the old technical space. And this is probably quite an important thing, because if you don't have visibility of the text transforms, then a lot of things won't work. So we would have to do something similar. However, it's not quite that simple as you would have thought, because the problem now is we need to find the right facet. So at the moment we're just taking all the helpers in one go, and it doesn't really matter. We just take them all, and once it matches we just shove it in. In fact, to be honest, I think the exact same approach will probably work. We just go scroll through the new facets, and if it matches an old facet, we will just push. Yeah, in fact, that would work really. So we could probably migrate these in fours. I think we could probably migrate the header and in twos. In fact, I think no, it has to be in fours. It has to be in fours because we need to migrate clearly the HPP and CPP, and the factory has to go along with the transform. Because if we don't migrate both at the same time, then it becomes wonky. We won't have the PMM side of things. So we need to migrate these in fours. Could do that. That probably will be just a rinse and repeat kind of exercise. So don't think it will be too complicated. Quite boring, but just needs to be done. What is slightly more exciting is the migration of the assistant. Now the assistant is a bit more tricky because the assistant overlaps. There's an overlap between the assistant in C++, in the C++ technical space, and the assistant in a C# technical space. So if we have a quick look at the assistant in the C# technical space, LSP seems to be a bit unhappy at the moment. Yeah, this guy. So as you can see here, we have certain amount of things that are similar. In certain cases, not quite what I meant to do. So if I just look for the C++ assistant. In fact, I probably won't find the C++ assistant. I will have to find the text assistant now because the C++ assistant has been migrated. So if we look at the text assistant, what we probably will see is some of these methods, well, some of them are actually identical. So in this case, this is actually the exact same method, just copied and pasted. So in that case, we don't really mind. Other cases, we may have the same name, not that particular one, but in certain cases, such as for example get qualified name, I suspect get qualified name would have the same name but different behaviors. And the reason being, of course, that these things are technical space sensitive. So for example, in this particular case, get qualified name is returns the colon representation, and this case will probably return the dot representation as you can see here. So what we need is some kind of way of knowing what technical space we're in. And I suspect, let's double check that we're not being called. Nothing major happening. So if we could somehow know what the technical space is, and we probably can because of course we are being passed in the model. You can see here we have the LPS. So if you have the LPS, you can go to the logical space, and from there you can obtain the output model, the output technical space. So you could use that. So I think perhaps this is not as complicated as we thought it would be. And certain cases, such as making the boilerplate formatter, here we probably hard-coded the technical space to be C#, I assume. In fact, we don't actually, so that is probably exactly as it is right now. In fact, we seem to do a lot more in the C++ things. So perhaps this is not quite as daunting as we first thought it would be. Seems like there's going to be a lot of copying and pasting. Say for example make namespaces. Do we have an equivalent? We do, and I assume okay, we just return a list, so that's probably identical, no problem. And there's going to be some C# specific methods here. Now, excuse me. As I said several times in the past, This notion of assistant is in itself flawed. Really, what we're calling here an assistant is, in effect, several things bundled in one. And as anyone that does lots of programming will tell you, whenever you have classes with names such as assistant, you know for sure that something's gone very wrong. The reason why is because if you have a name such as assistant, you can't determine reasonably from the name what his responsibility should be. Assistant, helper, manager, any class with names like that are normally just one big ball of things that get worse and worse over time. So we are very much against naming any class with names such as that. But there you are, we have one, and we have to deal with it for the moment. What we've done here is we try to make it a little bit more specific. So now it's an assistant in the formatter's namespace, so it's a formatting assistant. And in the future what we'll do is, well, when we have time, which will be not sure when, we will start taking things away from this class and move them to somewhere slightly more sensible. Certain cases these things should be represented in the logical model, or physical model perhaps. For example, this is a classic case. I'm not really sure. You should probably just have access to this, to the version somewhere in the element and things like that, so we wouldn't have to be querying it here. In fact, you probably should write a story for that. Sounds like a sensible thing to do. Also, our sprint is coming close to an end. Probably will finish in the next few days, so I think we will probably achieve both of our sprint goals, which is quite good, to be honest. Add technical space version to element. Not sure what I'm doing here. Oh, Control X, Control Q perhaps? No. Control C, Control Q then. Somehow I don't seem to have my usual normally you can add tags to okay, there's some kind of error when I try to do that. Specified root is not necessary. Specified, I'm not entirely sure what that error is, but let's just do a Control HK. Yeah, org set tags command. So that's kind of what we expected to see here. For whatever reason, that's not functioning at the moment. What happens if I try to kill this window? That's fine. The Max is behaving a little bit strangely. Ah, there we go. We should add the version of the TS to the element itself rather than querying it on the model. We probably should also have the major TS name in the element. We don't have autofill in the element as well. And with those two things we probably would save ourselves a lot of trouble in the helper, because half of the time we're querying for these things. And things like this, for example, requires manual default constructor. Really, this should be a property of an element and an object even. And you can see the craziness going on here, really. In fact, this is all extremely strange. Right, okay, so what we're doing here is we are casting that to a specific object type and then obtaining the value there. So this means that this is definitely a case where this makes absolutely no sense. We could easily do this in the right places. Instead of calling this method in the assistant, what we should really be doing is calling this method in the technical space properties, and then access it there, and there would be no reason for this method. Same with this guy. So as you can see here, I think probably we could very quickly with a lot of stuff here. Some of these things are problems in design, so I mean, basically this is a grab bag of problems. And I think if you go to each method here, you probably find that almost every method has got a right solution and is doing the wrong thing at present. But all of this is not part of the current exercise, I'm afraid. The current exercise is instead to try to just get us closer to a sensible architecture. So we shall start from the beginning, I guess. So the first thing we'll do is try to determine the technical space. This will be something like identification, entities, technical space, major technical space. And for this, we will just have to do a bit of, this is constant clearly. We just need a bit of hackery going on here. And that's basically to say, to be honest, we probably need another method actually, because given that this is a constant, we will need something like private. So we just need the LP. I mean, we don't really need the whole of the LPS, but it doesn't really matter. So retrieves the major technical space for the LPS. And so if we just return major technical space from this method, this should probably be static, so we can call it from the constructor safely. And now we do another set of hacks here. The idea here will be something like, so if I just do a const auto by reference TS, well actually, let's just get the logical model, LPS.logical, or even the output technical spaces, so let's call these DOTSs. Return. Now I'm going to do a hack here. I'm just going to say give me the front, because I know that it exists, and probably left to the references presumably. Something like this. So this is probably what, a list? Yeah, this is probably a list, so that's fine. Now of course in the real code you wouldn't do something like this, because of course you would have to check to see if the list has got elements in it. But in this hacked version of ours, we'll just get away with that now, because we know for sure everything is fine, because there are quite a lot of checks by the time you get here. And so we just need to make sure that order initialization is correct. I don't know why I didn't put that last, to be honest. Right, so now then, now that we have a major technical space for this LPS that we're in, we probably need to supply the LPS, of course. We can start to look at some of these methods. Some of these things we are just really going to do the quickest possible hack. So for example, in this particular case, this is only a C# function. We know no one else is using it. It's not very nice, but in the interest of time, we shall just copy and paste. It should just work. Couple of copy and paste more required. As you can see, this will only work if you're in C#. And if we were really doing this for long-lived code, we would check the technical space, make sure we return the right thing, and so on and so on. But of course, this is just temporary code, so we're not going to worry about that. Get qualified name. Similarly, we can do a quick hack. And here you can basically just say, not quite that, but so I probably need to, in fact, I think we might have a using already. We don't, so we just quickly add one. So if the major technical space is equal to the technical space of C++, we return that, else, well, we don't even need the else to be fair, but so again you can see here that we are not really doing this in a classic style that we would do, typical Dogen code. There's no lots of checks, we're not checking to see if there's another technical space here, we have a third language and so on. These are all valid concerns, and really one should take these into account. But before we add another technical space, we should really get rid of this class. And besides, we can always add the more bells and whistles in the future when we start rewriting some of this code. So next we have this inheritance. Right, so this will probably be I think we lost the plot a little bit here. Where are we? No, we've done that already, so these are not in the same order as they were on the other side. See, I hate when these things happen. So make scope operate for matter. I hope these are exactly the same methods, except as you can see here, we now have a default value here. I think this can no longer be defaulted. We have to take a different approach for this. We need probably to create a second method for this. What we need to do is, instead of defaulting it, we need to say, actually there are two kinds of methods. There's one that relies on the current major technical space, and another one that requires you to supply the technical space. So this won't break the interface. And then we can, in fact, to be honest, I think we should have done them the wrong way around, because this guy is going to call the other guy. So what we need to do then is to say something like double check that I'm not being called. Nothing happening. So as you can see here, what we can do is we can simply say, well, let's just delegate to your other dude, and let's just supply the major technical space version. And now we have an equivalent, roughly an equivalent behavior to what we had before with the defaulting, except it's now sensitive to the model. And so that means we can cope with both C# and C++, and so that should take us where we want to go. Make scope namespace format, as we've seen, that's fine. No, actually, let's just double check that, because I think we've seen the namespaces. No, it does look fine. We just have a quick look at this guy. Like just to be on the safe side, let's just double check that it is. Okay, bingo, I already spotted a problem. What we really mean to say here is major technical space. Okay. And then requires nested namespaces, needs to cater for the C# case. So we should say if the major technical space is equal to, so we could return major technical space is different from C#, because if it's C# there's no point. But having said that, we should not really be standard 17. But well, I'm not sure this is really required, but there you go. Basically what we're trying to say here is if you're C#, well, you're always going to use the dot notation for namespaces, so it doesn't really matter. And interestingly enough, so actually let's just have a quick look. How exactly does this nested namespaces gets used in the formatter? Because I suspect use nesting is set to false. Okay. Use nesting is set to false. So nesting, well, what exactly does use nesting mean? Let's think. Nested namespace. So I suspect okay, finally we got to the place where nesting is happening, so use nesting. So right, here we are. So use nesting. Yeah, so basically nesting so either we have a namespace or if we request to use nesting. So I think, well, it depends what you mean by nesting, I guess, but what we take nesting to mean is that we are going to create a single string with all the namespaces together with a dot. Now in this particular case, we're joining it using colon. That's because we're in C++, so presumably there will be a technical space somewhere, and that then determines what to do. And I bet you Format C# doesn't even bother to check for nesting, it just joins. Okay, cool. No worries. So it doesn't really matter really. The gist of this whole thing is it doesn't matter that we requires nested namespaces because this is not going to get used. So that's fine. What we'll do is to make this slightly less confusing, we shall leave this as it was because it's not really going to help to add C# there, and it's just going to make things a little bit more opaque. Make namespaces, I believe, add no differences, but of course we need to check. There it is. Just call the flattener. No worries, that's simple enough. And then we move over to reference equals. This is something that's a C# thing. So we need to copy that across. We shall put it here. exactly as it was in the original. And just below, make decoration preamble. Just here. So as you can see, this is not exactly the most exciting sort of exercise, but it's required in order for us to get to the next step. We will need this guy. Keep forgetting to set my bookmark. So there we are. This guy will handle that. And now let's look at comment. Right, this is different. Not entirely clear what's going on here. You have this notion of an indentation level. And we seem to indent for the comments. Okay, so definitely some special handling required here for C#. Clearly the lazy way to do this is to simply, given that these functions have got different signatures, of course there's an indentation level equals 0. But nevertheless, if the indentation level is equal to 0, presumably this will converge into the same behavior. So what we'll do is we will do exactly what we did a second ago. And we will just add a second method here with the indentation level. And then hopefully we'll end up with exactly the same behavior in a slightly different way. So if we just take this comment, I'm afraid I need to pause for a second. Right, apologies for this break. Afraid I need to go up and down every time the bell rings. So what we're trying to do here is, yes, we just created another method, and part of me actually is a bit lazy and says, in fact we probably will have to do that, because of course we can't really rely on the style here, because if the other method gets called, we'll be in trouble. So what we shall do instead is we will, well, first let's make sure these things are identical, and they're not. So this basically says, do not start in the first line, use documentation tool markup, documentation presents fine. Then we have the style, last line is blank. So we have one difference, which is start on the first line. Okay, so let's basically set these things here. So we probably could, I suspect this is going to be used in one place. No, it's used in many places. I think the behaviors will probably be quite different. This is interesting. These sort of small problems are the ones that end up causing a lot of bother. It's actually quite a trivial thing. We're gonna have to think about this for a while. So, how do we get the same behavior depending on the technical space? Okay, there's some more noises from downstairs. Okay, right, it's quite a lot of breaks here. Hard to get your concentration. Where are we? So we are trying to solve these annoying differences between C# and C++. Now, this is, make sure we started recording again. We did. This is in some ways exactly the kind of thing we want to see, because we want to observe where these differences start to occur. We want to understand how things vary dependent on technical spaces, and which things are configuration knobs of variability, as we call it in this model-driven engineering, and which things are actually natural properties of things, structural properties. So this is exactly why we want to see these things side by side, because what we're going to end up doing at some point is we will end up saying, well, actually, we should be modeling these as properties of our logical model, because these are actually fundamental properties of the technical space. So it starts off by this sort of hack, but it should really evolve towards proper modeling, so that you just pass the modeling element to this thing, and out comes the right comment formatter. So this is part of the observation exercise. So what we are observing here at the moment in terms of different behavior is that for whatever reason, in C++ we have this flag set to not, whereas we have it to true in in C sharp, and other than that everything else seems to be the same. Then we have the comment style that varies, and the rest is the same. So the first stab at this will be something like so I'm actually just going to create a variable here. Start on first line, which will be something like major technical space equals technical space C sharp. In fact, to be honest, as you can already see here, the pattern is going to be quite obvious, I think. So the pattern is going to be that this thing is going to be true for C sharp and false for not C sharp. So in effect, that is the pattern. So we could just replace this with that. And the second observation that we made was that the style was a variable of the technical space. So now of course you can imagine this is just a hacked version of this. So what we need then is another bool here. To be honest, it probably should be called start on first line that, but let's just put a comment here because clearly no one's going to remember what that means in a few months' time. So the second boolean is going to be, well, it's not quite a bool actually, the comment style. So if you just say something like using, and if we just create a const comment style, and now we can do, again, this is a bit of a hack as you can imagine, but hopefully it will be resilient enough to get us to when we get to refactor this. So as you can imagine, none of this will really survive if we had, say, more than one technical space, or the types of problems are too large to even consider at the moment. But the best way to think about this is to think that now we observe these patterns, we can now model this correctly, and once we model this correctly, we can then replace this in a generic across technical spaces sort of way. So if we've done our job properly, then hopefully we did, we should be able to now say, actually, replace all of this stuff, call that method, and give us exactly the same behavior. Now, before I go any further, what I'll do is I'm going to run some tests, because C++ would have been broken by now if we didn't do an equivalent replacement. This does touch every single model to text transform, so this is going to take a while to compile, so we'll keep going. Don't think we have a commenting line, so now we do have a commenting line, so let's have a look at what the commenting line does. Commenting line, so yeah, seems again very similar. Just the style is different. So again, this is a change we can do whilst the tests are running. In fact, I think in general we're gonna have. Well, okay, so the test passed. Okay, so what we're gonna do here is gonna do the following. We're gonna make this a little bit more slightly scalable, I guess you could say. Instead of doing this every 5 seconds, we're just gonna. This is really constant to the run, so there's no need for us to be computing the comment style every 5 seconds. So all we need to do is copy and paste the approach that we had a second ago, and comment style based on the major technical space. As a function of the major technical space. Right, so then what we do is we will just return the comment style, but then we will ask for the major technical space. And that will enable us to then say, well, for the entirety of this thing, just use this comment style. And put it around here somewhere. Right, okay, we had a lot of stop-start today, but I think we're kind of getting somewhere now. So, let's just locate whatever we were a second ago. This is why I use bookmarks. Let's look for comment style, I guess. Right, so the comment style would be no different from this. And then we did have bookmarks this time, we still didn't do it. So if I just return so if the major technical space, which in this case is the MTS, is equal to C#, then we would return, and I think the problem we have here is, oops, we didn't do a second bookmark. So the problem we're going to have, I should think, is not totally sure where we were. Oh, there we go. Let's put another F9 here. Okay, so now then, let's concentrate on this. So if we could just return the comment style from here, and if we could populate the comment style on construction, based on the MTS, then we could basically ignore all this nonsense there you go. So now what we want to do is we want to basically say wherever there's a reference to comment style, please don't hard code it, instead use this one that we computed earlier. As the English would say, the Blue Peter version. Right, so if we just go through all of these, now what we want to see then is to see that this does not cause anything to break. This is the MTS, clearly it should be const. Why is this moaning about comment style? Presumably because we only have comment styles in the we had a comment formatter but not a comment style. I wonder where comment style is defined. Let's put it here for a second. Here we are, comment style, and then let's take this guy, put it somewhere more sensible. Right, so I suspect, let's just get the test running. So I suspect that takes care of a lot of cases where comment style was being defined. Now, of course, you're probably going to say, well, how do you know for sure you didn't make other mistakes here? And of course, we probably did. But I think that's alright because the code generation didn't fail, so we don't need to worry about that. So that takes care of pretty much all these comments. The next thing is going to be this argument name in assistant properties. I think that these are two that we need. So if C++ does not break with this, it did. Okay, so whatever we did, we caused some bad breaks. Right, so okay. We wanted C++ style in certain cases. And I think it's only the enums. Yeah, so in the cases of the enums, okay, so that's not a big problem. So in the cases of the enums, we need to use C++ style. Right, so if I just drop these guys here for a second. Don't need this guy. And if I go back to where we were. So now we need to know what the context of this thing is. So if you are actually doing an enum, so best thing to do is to just have a quick look at the diff. Because the diff will show us exactly where the C++ style is being used. If I just look for comment style. So if you just look very carefully now for, there we are. So as you can see here, in this method, we are doing something slightly different. So, we can just jump there. So where we are saying here comment style, really, we don't really mean comment style because this is an inline comment, which is a bit different. So for this particular case, we can recompute comment style. And so we could say something like, let's see what we got on our clipboard. So if we just say we need comment style, and then we can say something like if major technical space, I guess. It's not really particularly clever. So if we take the major technical space, and if that is C++, presumably. I think I'm hearing noises now. So if, no, to be honest, we probably should start with something like const comment style, const comment style CS, and that is then going to be something like this. If the major space technical is C++, then we want whatever that was. Else, well, to be fair, I think it's just C# style, right? No, a lot of options here. And again, as you can see, this is clearly a very high degree of hard coding. But that's fine, we don't mind this kind of level of hard coding, that's not a problem. This will capture all the different variations, and really what you're seeing here already is you're now seeing that first, comment style becomes a logical model concept. We need to understand how the comments actually work at the logical model level. Second, we can see here that we associate the comments with the different elements that compose this logical model element. So we need some kind of way of actually adding a comment, for example, at the enumeration level, at the enumeration entry level, and so on, and such that when you are creating an inline comment, really what you want to do is you want to do this transformation in the right places. So in effect, the future of this will of course be that we provide all these transforms within the logical model, and then when we are formatting, we just basically ask for the comment. Okay, so that seems to have solved some of the problems, not all, which is interesting. So we still have a lot of problems with enumeration, so perhaps it didn't make a lot of difference. Let's have a look again. So, I think we probably didn't mean C style, did we? We really meant C++ style. That wouldn't really have made a lot of difference, I don't think. And so you see, and this is how this evolves, right? You first start off with a first we start off by hard coding, then we start by making it slightly more variable with things like these classes, then we start by modeling this correctly at the model level, and there we are, all tests are green now. So, and eventually it is finally modeled correctly at the logical model level. So, I think we got these two guys. Here. Now I suspect we'll have a few errors, just the one. And so this is kind of like, whilst it may appear that we are there's a lot of method in this approach, it's actually a fairly methodical approach. It's just that the approach, the type of method that we're using here is not quite the same kind of method that you use in real coding, in regular coding, I guess. It's more of a empirical approach to coding, that you wouldn't be able to do this in a real software house, I guess. And the main reason why, of course, is that there's a very heavy cost in terms of refactoring here. As you can see, we spend a lot of time refactoring. This would be completely impossible in a real programming place, because people will just not be able to afford that cost. Right, so I think at this point in time we have more or less captured everything about the assistants in our text model. So let's just call this text implement C# methods in assistant. Now we're very green in C++, so don't think we've made any changes to the text model itself. This is just cosmetic changes. It's good to just check these in, to be honest. One of the biggest problems we have by using a graphical representation is that you end up with a lot of noise. These changes, for example, add absolutely no value whatsoever. I mean, to be fair, it's probably something we moved for a reason, right? But nonetheless, it's from a coding perspective, you don't particularly care if something is moved by a few centimeters or something like that. And if you have lots of things in a diff, you can't really see what's changed. So it would be nice when the graphical elements are being removed from the model, really. Now then, the next step is to say what would happen if we deleted the assistant and all the references to the assistant became the text assistant. So we just regenerate this guy, go to git, we expect to see just a few diffs, and now, I mean, there's always two ways of doing this, but we'll go the RG way. So if I go to an empty area here, I yet again had to restart Emacs recently. This is just RG. So in this RG area, which is in fact going to be a grep area, to be honest. In fact, to be honest, what we're going to do instead is we are going to edit the model directly. So let's just open up a models area. Like honest. Reason being that it's much easier to edit the model for this kind of thing. Get rid of a few of these autosaves. If I just take this model, and now if I have a quick look for assistant.cpp, in fact .hvp, but what you see now, let's just go to the top of this. We saw this pattern in C++ as well, right? So the assistant is now going to be slightly different from what it was in the past. First, of course, is the include. Very simple thing to change. We can just do a big replace for that. The second thing is going to be how we call it. We don't need a context anymore, and so on. So what we'll do is for good measure, we will just have a side-by-side reference between C# and C++, and we'll start by getting rid of this guy here. So where we were mentioning the technical space, we stopped mentioning the technical space. In fact, there's more to it than that. We also need to make sure it's in the right namespace. So what we want to say then is formatters instead of transforms. Something like this. Dogen types formatters assistant-sheet. Right, so that takes us to the next change now. Now here you can see how we are creating the assistants in the past, and here you can see how we create the assistant these days. So let's just do a quick comparison between the two, and to be honest, we probably want to go to the very first entry here. There's not many of these in C#, so we can probably get away with doing this by hand if I'm honest, but I suspect we don't need to supply the header guard, but to be fair, I'm just going to set that to false. And that is it really. That is it. Just for a laugh, let's have a quick look at what the assistant says about the header guard. It could be defaulted, so... Or maybe we just didn't bother defaulting it. We didn't. Okay, cool, no worries. So, righty, so what we'll do then is we will just look for assistant space ASD, and manually, we could do search and replace, but I'm just going to go for manual for this time. I don't know why, but wouldn't expect any differences between these different entries. Fairly straightforward exercise, hopefully. There's not a lot of these guys either, so... I think we should have probably gone for search and replace now. Okay, there we are. So that then takes care of all of these guys. So now, what we're going to do is yet again we're going to generate, and now we're going to have a few diffs. So you can see there are not many, and then we're going to try to recompile this guy. Okay, no problems. We did a slight mistake. So when I said there shouldn't be too many differences, clearly I wasn't being accurate, because it seems that a few of these guys have different names. Not all are called assistants. So let's just see where that happened. I wonder if actually almost okay. Maybe it's because, well, let's do a search for assistant space AS and see if anything got missed. Well, I'm going to open a bracket. No, that definitely doesn't exist. Okay. So clearly I've lied when I said that the has function was identical. Clearly is not. Okay, so let's look at it again more carefully. Oop. In this particular case, we are providing an archetype, interestingly. No idea why we do that. Clearly, we decided in the future, in the thing of time, that wasn't really necessary. So okay, I really didn't want to start changing to templates too much, but there you are. Can hear some noise downstairs again. And so, a few of these cases where we're calling this cast function, we are supplying the ID, but we're not doing anything with the ID. I don't even particularly like this cast function, if I'm honest, but such is life. So what we're going to do then is we're going to get rid of these IDs, I think. I mean, it's not even being used. We are trying to minimize the footprint of this change, because one thing I guess that you learn as well as you become a more senior developer, it's always good to try to confuse as few things at a time as possible, because what tends to happen is, whilst you may think, oh, it's actually just a trivial change, while you add it, it may sound almost like laziness. Why would you not do that while you're there? But actually, you appreciate that when you get to the end of these transforms and there's a diff in the code, and you then need to explain why there is a diff. And what it does with all these little tiny changes that don't add any value to the overall mission, what they tend to do is they make troubleshooting of the final problems much harder. It seems like only a few lines of code here and there, but when you put them all together and you end up with a very large diff, at that point then you realize actually it was really not a very good idea to do too many things at the same time, because now you're trying to figure out why something is broken, and it's almost impossible to figure that out because all these other parallel changes that have nothing to do with it are just causing noise. So really the right way to have done this change would have been to say, first remove this in the C++, the C# model, the assistant, make sure it all works and compiles, and then remove it from the common code. However, this time we just took the gamble and it seems like it paid off. Sometimes you get lucky, I guess. Right, so now then, we could then say at this point text.c# use the common assistant on all M2T transforms. Right, and that also should mean, with a bit of luck, I'm not entirely sure, but I think, oh actually we don't need to guess, we can just jump over to the model. If we do a quick search for traits.cpp, HPP even, there are no references left to traits. So what we'll do at this point in time is we'll reopen our models. It's always good to close all of the text transforms after you've started messing around with them. It's sort of the raw representation. Because as you can imagine, we have done many a time where we didn't do that, and then we started reverting changes. Let's double check that we are recording. We're in an hour, into an hour. So now then, the last of our traits can get removed, and with a bit of luck as well, let's have a look. Formatting error should have been, yeah, we can also get rid of the formatting error. So we are very carefully, very slowly, incrementally getting rid of things in a way that we're sure is not going to break the world. Or if it does break the world, at least we know why, and we can address that. So this is now going to be text.c# remove traits and formatting error. And that will then take us to C# to in parallel to parallel is not quite the right expression, but take us to the same state of C# and C++, and we need to make sure that these guys are also in the same state. So what do we think now? We think that if we were to just simply add artifacts to our hack, and the hack is somewhere around here, bootstrap. So if we were to do exactly what we did here and iterate through yeah, so all we need to do, I should think, to say something like for const out. Actually, first, before we do that, let's just see what's inside of a facet. Archetypes, perhaps. Not getting huge amount of help from LSP at the moment. Wonder what we've done here. Let's first get this thing green again. So all we're trying to know is, do we have, well, text, physical. Bit of chaos going on downstairs. Okay, so I think I'll probably do is we'll break this into videos, to be honest. This is already becoming a bit longer now, to be honest. This is going to take a while, and I can hear quite a lot of noise downstairs, so I probably need to deal with that. So all we need to do for the next video, we're going to do this. So we've now put C++ and C# in the same state. What we'll do in the next video is we'll start moving these guys. I think all we need to do, in fact, we'll just do that before this video is finished. Won't take too long. We just need to go to the physical model, and in the physical model, try to understand what's in the facets. And as you can see here, there's the archetypes. So literally, all we need to do is to say, well, take my archetypes. Exactly. So what we're trying to do is something like this. This could be very dodgy, so I could just call this all pair 2 maybe. Or do I call this all pair 2? Probably new pair actually. So what are we merging? We are... Yeah, so perhaps what we really need to do is to say take all of the new facet archetypes and old facets dot insert the new pair. Sorry, old facet dot archetypes dot insert the new pair. So hopefully what this will do is it will grab all the archetypes that exist in the new facet, and it's going to take them into the old facet, and then as you can see here we are creating old facets, and then we're pumping that through the lambda. And so hopefully the end result of this is that the old facet will have everything that's in the new facet. So that quick hack should, in theory, but first it should do nothing, hopefully, which is what we're going to leave it at for this video. If we are still recording. And so what we'll do is just for this video we'll just say orchestration, copy across archetypes from new backend to old backend. And that's just a very quick hack that we're doing there. And then what we'll do is when we come back for the next video is hopefully we'll be able to just lift and shift these guys over to here, change a couple of things in the templates, and then recompile. And in theory, that should be it. And if it's not, then we'll have to deal with the fallout. So thanks very much for watching this part.